Thanks a lot for joining me in this talk about architecture for flow with Wardley mapping, domain-driven design, and team topologies. Most initiatives that try to change or to optimize a system are usually directed at improving parts taken separately. They tend to focus on local optimization of the separate parts of the system. But from a system thinking lens, local optimization of separate parts will not improve the performance of the whole. Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that a system is more than the sum of its parts. It's a product of their interactions. The way parts fit together determines the performance of a system, not on how they perform taken separately. He also claimed if the systemic nature of an organization is ignored, the effort of improving and changing that system are doomed to failure. When building systems in general, we are facing the challenge between building the right thing and building the thing right. Building the right thing addresses effectiveness and addresses questions such as how aligned is our solution to our user needs? Are we creating value for our customers? Have we understood the problem and do we share a common understanding? Building the thing right, on the other hand, focuses on efficiency. For example, efficiency of engineering practices. And it's not only crucial to generate value, but also being able to deliver that value. And about how fast can we deliver changes and how fast and easy can we make a change effective and adapt to new circumstances. The one does not go without the other, but as Dr. Russell Eckhoff pointed out, doing the wrong thing right is not nearly as good as doing the right thing wrong. So by considering the whole and having effectiveness and efficiency in mind to build the right thing right, we need a holistic perspective to build adaptive systems. And one approach that I would like to share with you today is combining the perspectives of business strategy with Wardley mapping, software design and architecture with domain-driven design, and team organization with team topologies in order to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of change. So let's put these three perspectives together by evolving a legacy system. And we are using a fictitious example of an online school for junior students based on a legacy system built, run, and supported by functional silo teams. The first step to evolve our system is starting with a team and analyzing their current situation in regards to their team cognitive load and encountered delivery bottlenecks. Due to handover, the functional silo teams reported high communication and coordination effort between teams when implementing and releasing changes. Dealing with a monolithic big ball of mud with a messy model and no clear boundaries leads to high cognitive load and tight change coupling. And it takes a high amount of effort to understand a piece of code. In addition, the teams reported about no clear ownership boundaries, and they are facing, in general, with delivery bottlenecks and impeding their software delivery performance. And due to on-premises infrastructure, the operational activities consist of configuration, backup and recovery mechanisms, maintenance, including upgrades and security updates, scaling, monitoring, and so on. So the infrastructure team face very high operational efforts. But as a reminder from system thinking, if you plan to optimize only separate parts, it does not improve the performance of the whole. Improving the performance of the whole requires to tackle the situation from a broader perspective and also understand the environment an organization is operating and competing in. And this brings us to a Wardley map representing the context-specific landscape of an organization. A Wardley map is part of Wardley mapping. Wardley mapping is a strategic framework invented by Simon Wardley, and it helps to design and evolve effective business strategies based on situational awareness and movement following a strategy cycle. The strategy cycle is a representation of change and how we need to react to that change according to Simon Wardley. It starts with a purpose, the why of our business, in our case, providing high quality education for junior students everywhere and help teachers to engage with their students online. The next section of our strategy cycle is the landscape an organization is operating and competing in, which is visualized with a Wardley map. So let's create a Wardley map of our online school example. A Wardley map is in general composed of an y-axis and an x-axis, and the y-axis represents the value chain. To derive a value chain, it starts with identifying your users first, and your users can be customers, shareholders, staff, business partners, internal users, and so on. So we are going to focus on the teachers and the junior students as the users of the online school. Next is identifying the user needs. And the user needs are addressing the problems the users would like to get solved. They are the subject area for which we build a product. And the users and the user needs, they represent the anchor of the map that all subsequent components relate to. So the teachers would like to create course content for the students. They would like to plan a class, supporting the students during their studies, and also evaluating their progress. The students have the user needs of studying courses, requesting and receiving help during their studies, and receiving evaluation feedback. Both teachers and students, they need to sign up and sign in as well. Next, we are identifying the components that fulfill the user needs either directly or indirectly by facilitating other components in that value chain, and determining the dependencies and the positions in the value chain. So at the top, we have components that are most visible to the users, so where the users are touching the system, and at the bottom, it gets more and more invisible to the user. And the value to the user and the visibility, they are closely correlated. So the more visible a component is, the more value it provides to the user. The component that the teachers and students are interacting directly with is the online school component. It's located at the top of the value chain. So at this point, we are dealing with a monolithic big ball of mud as one single component that we are going to decompose later into modular components when we talk about the second perspectives of domain-driven design. And the online school component, this depends on infrastructure components such as data storage, search engine, message broker, SMTP server, and compute platform running on top of a virtual machine component. So they are less visible to the users and placed further down the value chain. Now each component of this value chain is going to be plotted along an evolution axis going from left to right. So at the left, we have Genesis with brand new things, then custom built, then product and rental, such as off-the-shelf products or open source software solutions, and then things on the right like commodity and utility. For determining the stage of evolution per component, let's look at a couple of climatic patterns that are influencing our landscape. That's where we come to the next section of our strategy cycle, the climate. Climatic patterns describe external forces that are impacting our landscape over which we have no control. However, understanding climatic patterns is important when anticipating change, according to Simon Wardley. Understanding climatic patterns gives us an idea where the landscape can change and where to invest in the future. One pattern is that the landscape is never static, but very dynamic. So everything evolves from left to right through the forces of supply and demand competition. For example, cloud-hosted services are reflecting this climatic pattern. What was decades ago non-existent evolved through Genesis, custom built, and became product and rental, and now commodity and utility. As the components evolve, their characteristic change from an uncharted domain, an undefined market, uncertain, unpredictable, constantly changing, poorly understood, chaotic domain. And while it evolves and becomes more and more stable and mature, and where we are then facing an industrialized, mature, known, commonly understood, ordered market on the right. And we can use these characteristics to determine its stage of evolution per component. So the online school component is reflecting a volatile component that is changing frequently and that is providing competitive advantage. It shall go into the custom built evolution stage. The more stable, mature, widespread infrastructure components, on the other hand, can go in product and rental or commodity and utility evolution stage. And for each evolution stage, we can apply appropriate methods. That's where we come to the Wardley doctrine, the next section of the strategy cycle. Doctrine describes universal principles that each industry can apply regardless of their context. And applying doctrinal principles enables an organization to be able to respond to changes quickly and to be able to absorb changes gracefully. So one of the doctrinal principles is using appropriate methods per evolution stage. And it means to build components in Genesis and custom build in-house, preferably using agile methods, or using or buying off-the-shelf products or using open source software for components in product and rental evolution stage with preferably lean methods, or outsourcing components in commodity to utility suppliers or using preferably Six Sigma methods. So coming back to our online school, we are going to develop the online school component in-house. And for the infrastructure components such as search engine, data storage, message broker, and so on, we are using open source solutions at the current state. And the virtual machine component is provided by a server hosting provider as an off-the-shelf product. And with the water map at hand, we are already applying doctrinal principles. So one of the doctrinal principles is that we know who our users are. We know their user needs and we can focus on them as another doctrinal principle. We know the details in terms of what is necessary to fulfill the user needs and generating value by solving the user needs. And it also depicts what to build in-house and where to use off-the-shelf products or open source software and where to outsource to utility suppliers. And we can share and discuss this map with others to challenge assumptions as another doctrinal principles in order to create a better map and a better understanding, and using a common language to be able to communicate effectively. And we are going to use this map as a foundation for future discussions while evolving our legacy system. So let's go back to the team perspective. To optimize for flow of change from a team perspective, we need to avoid functional silos with handover. Instead, we need to aim for autonomous cross-functional teams that are designing, developing, testing, deploying, and operating the systems they are responsible for. And we need to avoid handover so that work is never handed off to another team. We need to use small, long-lived teams as the norm. And the teams need to own the system or subsystem they are responsible for. So they need to have end-to-end responsibility to achieve fast flow. We need to reduce the team's cognitive load. So if the team's cognitive load is largely exceeded, it becomes a delivery bottleneck and leading to delays, quality issues, and so on. And while the communication within a team is highly desired, we have to restrict a high communication bandwidth between the teams to enable fast flow. And that's where team topologies can help us with their well-defined team types and their well-defined interaction modes. So we have the autonomous cross-functional stream-aligned teams that are aligned to a continuous stream of work focusing on a fast flow of changes. And to be able to focus on a fast flow of changes and to be able to produce a steady flow of feature deliveries, they need the help from the other teams. For example, they need support from the platform teams that are responsible for platforms that usually abstract away infrastructure and networking or cross-cutting capabilities. And they provide internal self-service services and tools for using that platform that then the stream-aligned teams can easily consume. Or they need the help from the enabling team that help the stream-aligned teams to acquire missing capabilities. Or the complicated subsystem teams as an optional team type that are supporting the stream-aligned teams on particularly complicated subsystems that require very specialized knowledge. And they all aim for increasing the autonomy and reducing the team cognitive load of the stream-aligned teams to enable fast flow of change. To arrange the teams into the team types is not enough to become effective. So how these teams are interacting with each other and when to change and evolve team interaction is also very relevant for high effectiveness. So with the interaction mode of collaborations, teams are working very closely together, aiming for a common goal. And this interaction mode is suitable for rapid discovery and innovation, for example, when exploring new technologies. X as a service suits well when one team needs to use a code library or a component, an API or platform that can be effectively provided by another team as a service. And it works best where predictable delivery is needed. Facilitating this is the interaction mode that comes into play when one team would benefit from active help of another team. And this interaction mode is typical for enabling teams. So the combination of this well-defined team types and this well-defined interaction modes promotes organizational effectiveness. And while we're applying team topologies, it also helps automatically to apply Wardley's Doctrinal Principles. So let's come back to our previously created Wardley map of the online school. And so optimizing for fast flow of change requires to know where the most important changes in a system occur, the streams of changes. And the type of streams can differ in every organization, ranging from task, role, activity, geography, and customer segment-oriented stream types. So in the current online school example, we are focusing on activity streams represented by the user needs of a Wardley map. And the user needs of creating course content, planning classes, evaluating students, and so on, they are good candidates for activity-oriented streams of changes. So they need to be focused on when optimizing for fast flow. So let's address next the problem domain. The user and the user needs of our Wardley map are representing the anchor of the map, but also representing the problem domain in the domain-driven design context. And understanding the problem domain and partitioning it into smaller parts, the subdomain, could be then the next step. So that's where I would like to bring in then the next perspective of software architecture and design with domain-driven design. So domain-driven design is about designing software based on domain models, first proposed by Eric Evans. And it comes with a core statement: in order to build better software, we have to align its software design with the business domain, with the business needs and the business strategy. And while applying domain-driven design, we also it also helps to apply doctrinal principles of Wardley mapping. Domain-driven design comes with patterns and practices of strategic and tactical design. In the problem space of strategic design, we are analyzing the problem domain and distilling the problem domain into smaller parts, the subdomains. But not all subdomains are equal. Some are more valuable to the business than others. So we have different types of subdomains, such as core, supporting, and generic. The core domain, that is the essential part of our problem domain, providing competitive advantage. And it should be hard for competitors to copy or imitate. It's supposed to be complex, and it tends to change often. So that's where we have to strategically invest most and innovate on. So that's a subdomain we need to build in-house and supposed to go into Genesis or custom-built evolution stage. The supporting subdomain helps to support the core domain. It does not provide any competitive advantage. It's quite simple. They do not change often. And if possible, we should look out for buying off-the-shelf products or using open source software that goes then in the product and rental evolution stage. And if this is not possible, and if we have to custom build the supporting subdomain, we should not invest heavily in that part of the system. The generic subdomain, these are subdomains that many business systems have, for example, authentication or payment. So they aren't core, they provide no competitive advantage, but businesses cannot work without them. So they are generally complex, but already solved by someone else. So buying off-the-shelf products or using open source software or outsourcing to commodity suppliers should be applied for the generic subdomains. There is no need for innovation here. So in general, these different subdomain tabs can help us to prioritize the development effort that we should invest most in the core domain providing competitive advantage. In regards to our online school, the user needs of creating course content, planning a class, learning support, and studying courses, they fall into the resort of the core domain. So they provide competitive advantage, leading to a high level of differentiation. They embody complexity, and they tend to change often and are not widespread in every other business system. So it is the core domain that we will want to strategically invest in most, and that's where we will have the most opportunity for innovation. On the other hand, the evaluation of student progress and learning does not necessarily provide a competitive advantage, but it supports the teacher's experience and is necessary for the organization to succeed. It tends to be less complex and change less frequently. So we should not invest too much in that subdomain since it does not provide competitive advantage. The user needs of signing up and signing in, they embody user needs of a generic subdomain, and many business systems need the subdomain of registration and authentication, so they are widespread, standard, and expected with a high level of ubiquity and a high level of stability. So they are not core, do not provide a competitive advantage, but without registration and without authentication, the online school solution would not work securely. So they are generally complex, but already solved by someone else. So there exist several solutions on the market already. So there is no need for innovation and strategic investment here. Next, we can switch to the solution space of strategic design, and that's where we are going to decompose our monolithic big ball of mud into smaller modular components, designing then the bounded context. And a subdomain can contain, in the ideal case, can contain one, or in some cases also more than one bounded context. A bounded context defines where a single domain model can be applied and forms a unit of purpose, mastery, and autonomy. And a domain model itself that represents the domain logic and business rules that are relevant to that area of the system. And a bounded context can provide different types of boundaries. So it can form a linguistic and semantic boundary so that the language's terms of the domain model are only consistent inside of its bounded context. It also serves as an ownership boundary. A bounded context should be owned by one team only. However, a single team can own multiple bounded contexts. Sorry. Bounded contexts serve also as a physical boundary and can be implemented as separate solutions. And not all bounded contexts need to share the same architectural and business logic implementation patterns, so they can differ from context to context. So in this example, we might have derived several bounded contexts with their appropriate methods. So content creation, class management, course studies, and learning support, they fulfill the core domain related user needs. So they are strategically important and require most development effort. So they go into the custom build evolution stage and are going to be built in-house. Student evaluation and notification handling belong to the supporting subdomains. There might exist solutions on the market already, but the team decided that a higher level of specialization is needed to build them then in-house. However, the development investment should not be too high since they do not provide competitive advantage. The identity and access management bounded context belongs to a generic subdomain, so there exist several solutions on the market already, and it should go either into product and rental or commodity and utility evolution stage. Next is finding suitable team boundaries, and as I said earlier, the bounded contexts serve as well-defined ownership boundaries, forming a unit of purpose, mastery, and autonomy. So bounded contexts are indicating good seams to split the system into smaller parts. And on the other hand, they also work as suitable team boundaries for the streamlined teams. To optimize cognitive load, we have to limit the number and size and complexities of software system a single team has to work with. And this brings us to the evolution stages of Wardley map. According to the characteristics of the evolution stages, the further left bounded context or a component in general is located on the Wardley map, the higher the level of uncertainty is, which requires then practices that are focusing on exploration and discovery. So bounded contexts in Genesis or components in Genesis tend to change far more frequently than components in commodity. For components residing in commodity, we can draw on best practices solutions, providing a clear path to action. So each evolution stage addresses different practices for their related paths to action, ranging from best, good, emergent, and novel practices. So the more unclear the path to action is, the higher the level of cognitive load is. That means that a single team could take ownership of more or larger bounded contexts and components that are residing in commodity than residing in Genesis. Another aspect to optimize for team cognitive load is to establish clear responsibility boundaries. And for clear responsibility boundaries, we need to assign each bounded context to a single team and not sharing bounded contexts across teams, because that would then diffuse the ownership of teams. However, one team can own several bounded contexts. The next step is identifying services that are needed to support a reliable flow of changes. And that brings the focus on the infrastructure and platform-related components of our Wardley map, located in product and rental and commodity and utility evolution stage. In order to be able to focus on a fast flow of change, the streamlined teams are relying on a platform team, providing an easily consumable platform as a service. And this platform shall reflect a Sinus viable platform that is just big enough to fulfill the user needs of its consumers and shall not become bigger than needed. And the Sinus viable platform could start with documentation, standards, best practices, templates, and can evolve later into a digital platform with self-service APIs and tools. We also need to mind the dependencies and communication bandwidth between teams. Are there tightly coupled or blocking dependencies or a high amount of ongoing communication and coordination efforts between teams? They need to be eliminated. And identifying capability gaps and helping teams to acquire missing capability is then the responsibility of the enabling teams. So the previous consideration might result in this illustrated team constellation. In general, most teams in an organization shall be cross-functional, autonomous, streamlined teams. And so in our case, in our example, the 4 core domain-related bounded contexts residing in the custom-built evolution stage, they are going to be split among 3 streamlined teams, and the supporting and the generic subdomain-related bounded contexts of this example are going to be handled then by another streamlined team. And the infrastructure components then will be taken care of by 1 or more platform teams. But before we are going into the transition and implementation phase, we need to mind potential efficiency gaps. So we want to avoid building or evolving a system based on inefficiencies, because inefficiency would also impede the fast flow of change. So if the evolution stage of the components we are using in our organization internally differ from the ones that are available in the market, that might indicate an efficiency gap. For example, if we are using custom-built components, but the components in the market are available as commodity, we are lagging behind and encounter potential inefficiencies. And the bigger the gap, the less efficient the organization might be. So, we need to close this efficiency gap, and one approach to close the efficiency gap could be done by migrating components from on-premises infrastructure to the cloud. And that's what we are going to address in a minute. So at this moment, we have not transitioned anything yet, but we did prior architectural and design considerations. And now the question arises, how do we transition and implement flow optimization? So to close the previously mentioned efficiency gap, we want to migrate the components from on-premises infrastructure to cloud-hosted services. And the cloud migration could start with a team-first approach. And the cloud migration is going to be supported through dynamic reteaming and an evolution of team topologies. Since we are addressing infrastructure components, we are starting the transition with forming the platform team first from members of the previous backend and the previous infrastructure team. And this new platform team is working on the side with the freedom to learn and explore and discover and assess cloud migration strategies. This new platform team can then determine a migration plan and its new target platform. So in the example of the online school, we are starting with the replatforming cloud strategy. And with replatforming, we are modifying the underlying infrastructure by replacing on-premises infrastructure components with cloud-managed services, while we keep the applications architecture the same. So with replatforming, we are offloading the management of the infrastructure components to the cloud provider and reducing then the operational efforts on our side, and also improve performance, scalability, and elasticity of the infrastructure itself, and we are going to close efficiency gaps. So once the on-premises infrastructure is fully migrated, the cloud environment to the cloud environment through replatforming, the remaining infrastructure team and the previous platform team can merge into a joint platform team. So even though the resulting team is becoming bigger, it makes sense in some cases to merge teams when we want to bring collective intelligence together, and when the joint teams leads to a higher flexibility and to higher fluidity than having separate teams. So for example, in our case, the merged team is able to share their previously gained cloud knowledge from replatforming then with the new team members, for example, by pair programming. And the merged platform team can split later then in smaller teams if this is applicable. So far we have replatformed our infrastructure components, but we also want to modernize our monolithic big ball of mud and eliminate its related bottlenecks. That brings us to the next level of cloud migration by refactoring the application's architecture. And refactoring typically involves breaking down the application into smaller components. So in the example of the online school, we want to break the monolithic big ball of mud apart by incrementally decomposing it into our previously designed bounded contexts. To start the refactoring journey, we are forming first streamlined teams from members of the previous front-end and back-end teams. And the refactoring journey is supported by an evolution of team topologies interaction mode. So at the beginning, the streamlined teams, they can closely collaborate with the platform teams, to jointly discover and assess potential cloud options for the future bounded context that the new streamlined team is responsible for. And the streamlined team might decide to refactor their bounded context using serverless technologies. As soon as potential options were discovered and knowledge was shared, the interaction can go then into limited collaboration and limited facilitation mode. So going from daily to occasional on-demand interaction. And at a later stage, this can then evolve to X as a service once the serverless ecosystem is more established in the organization, where then the platform team provides best practices, standards, tools, APIs that then to easily consume the cloud services. In the meantime, the remaining front-end and back-end teams can merge into a preliminary joint team, which takes care of the remaining monoliths as long as it's existing, and as one team with no handover involved. And from there, they will then incrementally split into their separate stream-aligned teams. In these new formed stream-aligned teams, they receive active help from the previous stream-aligned and platform team during their cloud journey. So the cloud platform team can suggest possible cloud options that are applicable for their bounded context, and they can coach them how to use a new build pipeline in a serverless ecosystem. And they can also point to the platform as a service it has established before and incorporate their feedback while they are using it. And the previous stream-aligned team can share their knowledge with the new stream-aligned teams, for example, coaching them about best practices or how to implement serverless functions using hexagonal architecture, for example. So that at the end, we have refactored our monolithic big ball of mud into modular components based on serverless technologies. So at this stage, we have transformed our functional silo teams with handover into well-defined team types and interaction modes, and could restrict the formerly high communication and coordination bandwidth between teams. We could decompose our monolithic big ball of mud with a messy model and fuzzy boundaries into a system with clear bounded contexts and domain models. And with bounded context, we can establish well-defined ownership boundaries. We moved from tight change coupling to a loosely coupled system and optimized the team cognitive load, so that we could eliminate delivery bottlenecks and improve the software delivery performance. In addition, we could reduce the high operational efforts by migrating on-premise infrastructure components to cloud-hosted services and close then the related efficiency gap. So at the end, the combination of Wardley mapping, domain-driven design, and team topologies that helps to understand the environment an organization is operating and competing in. It also helps to understand the climatic patterns that are impacting the landscape, and also helps to apply doctrinal principles that enables an organization to be able to respond to changes quickly. The combination helps us to gain domain knowledge and discovering the core and providing competitive advantage. It helps us to know what components to build in-house, where to buy or use off-the-shelf products or open source software, or where to outsource to utility suppliers. It helps us to decompose the problem domain into modular components. It helps to align the teams and evolving their interaction to the system we build and the strategy we plan. With this combination, we are able to identify potential efficiency gaps and trying to eliminate them, close these efficiency gaps. And it helps us to eliminate bottlenecks and increase the software delivery performance, so that we are then able to respond to changes quickly and absorb changes gracefully. And the combination of Wardley mapping, domain-driven design, and team topologies, that's providing a powerful holistic tool set to design and to build and evolve adaptive socio-technical systems that are optimized for fast flow of change, with a focus on improving the performance of the system as a whole. And with that, thank you so much for attending my talk, and I'm looking forward to your questions.
Thank you, Susanne. That was great.
Thank you so much for attending.
The only problem now is I've got so much cognitive load that my brain feels like it's going to explode. So I need something like some kind of platform to help reduce my cognitive load and help me understand it. But anyway, yes.
I apologize for the information overload. It's really challenging to bring together the three perspectives in just 40 minutes. So thanks a lot for your patience.
So we'll come to some questions in a minute, but I just thought I'd start by asking, kind of what feels like a good way to start with this approach? Could you provide some advice for people who are, let's say that they've seen the talk, they can see the value of Wardley mapping, domain-driven design, and team topologies together. What feels like a sensible approach to start at, let's say, an organization it has like 1,000 people, so it's relatively small, and maybe like 600 engineers in total, that kind of size, and maybe they're doing something. They've got some kind of online service, something like that. Well, where would be a good place to start to use these techniques, and then how would you go about doing it?
Yeah, so it's you can start at differently. So, for example, what I like to start with is addressing the current state where you're at right now. So, what are your current challenges that you're dealing with? So, you can start with analyzing, with asking your teams, as you also suggest in your team topology book, where you address the team situation in regards to the team cognitive load and communication and coordination efforts between teams. You can survey style, for example, that you ask every teams regarding the challenges that they're facing. And another aspect that you can bring in is to create a Wardley map of your current situation. The Wardley map that is representing the environment an organization is operating and competing in. And it's usually, so every team itself can create their own Wardley map, but they also can share their map and discuss it with others. I guess it has its greatest value to the communication that you have between, because that is, for example, your view of your landscape that your organization is competing in, but sharing it with others and communicate with others and also see blind spot that you have not seen before. It's really a great tool to know where you are. So what is your current landscape, where you're operating and competing in? What are your challenges of your teams regards to communication, coordination effort? And also what is necessary. You could follow, for example, also when you create this Wardley map of the web value chain, you can also identify what is necessary, what components do you have to touch, and what teams are responsible for the specific components, and which teams need to communicate and coordinate effectively to make this change effective. So we can use this Wardley map as a foundation to identify bottlenecks.
It feels like a really key aspect, isn't it, to empower the teams to give them these tools, like being able to use Wardley mapping, think about things in terms of bounded context from DDD, and obviously use the ideas from team topologies about team interactions and limiting cognitive load and so on. But to empower these teams to use these techniques as part of their toolkit, if you like, so that they can have much more informed conversations, much better conversations, and share that with other teams. Say, well, from our perspective, it looks like this. What's it look like from your perspective?
Yeah.
Because it's not about, we're not trying to find a single perfect map or view. We're looking for multiple perspectives to give us additional insights effectively. Because no one group is going to have all of the knowledge and awareness.
No, and then it's going to be not only one map, right? So if you have a larger organization, then, for example, we have your platform. If you have platform teams that are providing the platform, they have a totally different Wardley map than those that are end-to-end responsibility or close to your to the customers, the Streamline team. So they have different users and with their different user needs, and the platform team can create their own Wardley map, where you as a Streamline teams are then the internal users, and you have then the user needs of designing and deploying and building your application, where you then also need help support from enabling teams regards to application security, testing, the software design, and so on. So there could be also from the enabling team a different Wardley map as well, where you then can focus on your specific users of the Wardley map, and you can put them then together. So, for example, the Wardley map of the platform team, they will then be an aggregated component in the platform as a service, for example, could be an aggregated component in the Wardley map of the Streamline team. So, and also helps you together, for example, if you have multiple platform teams, if you're maybe using, if you lay them on top, then you can also identify whether you are using duplicated components, for example, I don't know, for CRM systems, and then you can also see it visualizes also duplications that you can reduce it then to one component, for example, if that makes sense in your context.
Yeah, exactly. It feels like these things are definitely heading in the direction of we're not looking to create a perfect machine. We're looking to kind of have an ecosystem, and there's different perspectives. We're not going to be able to design this thing with just one perspective. I think that feels like an important, like, kind of industry move, industry trend.
Yeah.
I'm just having a look. So this room's going to close in less than 5 minutes. What's that? We're going to close in a couple of minutes, actually. But we'll take these conversations onto the Zoom chat in a few minutes. So I think what we'll probably do is actually go straight there based on the timings that we've got now. 7, yeah, because the room's going to close in basically a couple of minutes. So head over to, we've got the instructions in the chat. Thanks, Julia. Head over to the schedule page and you'll find the coffee break chat link in there against the schedule entry for Susanne's talk. So if you want to continue the conversation, join us there in a minute or two. And see you very soon.
See you there.
See you then. See you there. Bye-bye.